Imagine trying to synchronize two massive banking transactions happening at the exact same millisecond, like one in Tokyo and one in New York.
Right, which sounds basically impossible.
Yeah, computer science said perfect accuracy at that distance was impossible without massive delays, until Google decided to put literal atomic clocks into their data centers.
It totally sounds like science fiction, but that's the reality of modern enterprise architecture. And, it's exactly why we're doing a deep dive on Google Cloud's database portfolio today.
Okay, let's unpack this. Our mission for this deep dive is to shortcut your way to understanding how these GCP database engines actually fit together for you, trade-offs and all.
Because it's a really dense ecosystem, and if you don't understand the underlying mechanics, you're going to architect yourself into a very expensive corner.
Totally. So let's start with the relational side. We all know Cloud SQL. It's your reliable daily commuter car. Standard apps under 64 terabytes, you're good to go.
Exactly. But what happens when you outgrow that? That's where you hit the first architectural fork in the road. You can scale vertically with AlloyDB or globally with Spanner.
Right. So AlloyDB is like the sports car.
Yeah, it takes standard PostgreSQL and fundamentally alters the caching and storage layers. It gives you like 4 times the transactional speed.
Oh, wow.
Plus, it has AI vector search built right into the core. So instead of just querying exact text matches, you can query data by its underlying meaning, or similarity.
Which is obviously crucial for modern AI applications. But wait, if AlloyDB is so fast and capable, why do we even need Spanner? Like, why not just use the sports car for everything?
Because AlloyDB is still fundamentally regional. When you need extreme global scale, what's fascinating here is how Spanner breaks the oldest compromise in tech.
You mean the whole horizontal scale versus strict consistency thing?
Right. Historically, you had to choose between infinite horizontal scale spread across the globe or strict ACID consistency, meaning every transaction is perfectly reliable and perfectly ordered.
So, meaning if someone buys the last pair of sneakers in Tokyo, someone in New York doesn't accidentally buy that exact same pair a millisecond later.
Precisely. Spanner achieves both using true time, those atomic clocks you mentioned earlier.
It's just wild to me that they use literal atomic clocks.
I know, right? By knowing the absolute exact time down to the microsecond across every global data center, Spanner can serialize transactions. And it does this without needing data centers to constantly ping each other over the network for permission.
Wow, so it just prevents transaction collisions mathematically, giving you that 99.999% SLA.
Exactly. It's the global bullet train. But, that makes perfect sense for highly structured relational data like core banking.
Right, but here's where it gets really interesting. Say I'm building a real-time mobile app where the data is messy user profiles, live chats. You don't want rigid rows and columns for that.
No, definitely not.
You want a document database like Firestore, where data is stored as hierarchical JSON. It's entirely serverless, right? So it just handles offline state for mobile users automatically.
Yeah, Firestore is brilliant because it pushes the synchronization logic down to the client level with zero capacity planning. But you have to be very careful with its use cases.
Well, let me challenge that. If Firestore is serverless and scales automatically, why can't I just use it for, say, tracking millions of global IoT sensors? Data is data, right?
Because data structure dictates write speed. If millions of sensors ping Firestore every second, it buckles. Updating complex, hierarchical JSON documents requires reading the document, locking it, modifying it, and then rewriting it.
Ah, I see. So there's too much friction for that kind of volume.
Exactly. For a relentless, heavy write pressure, you need the cargo ship. You need a wide column store like Bigtable.
Because wide column stores handle the incoming data completely differently.
Yes. Bigtable essentially uses an append-only architecture. Instead of opening and locking a complex document to update a sensor reading, Bigtable just slaps a new time-stamped column onto a massively flat, wide table.
Bypassing the locking overhead entirely.
Right. And that's how it ingests petabytes of telemetry with single-digit millisecond latency.
Okay, so now I'm picturing a massive enterprise running all of this at once. You've got AlloyDB handling AI workloads, Spanner running the global core banking, and Bigtable swallowing petabytes of IoT data.
It's a lot to manage.
Yeah. How does an enterprise not lose its mind? How does a CCOPS team keep track of this without a massive manual auditing nightmare?
Well, that's the classic problem of database sprawl. You inevitably end up with single points of failure hidden in the architecture. But to solve this, Google introduced Database Center.
Right, which integrates Gemini AI directly. I was reading about this in the guide.
Yeah,
You can actually query your fleet's health using natural language.
it can.
But how much of that is like a gimmick versus an actual governance tool?
If we connect this to the bigger picture, it fundamentally changes governance. You aren't writing complex scripts to check your fleet anymore.
Oh, wait, really?
Yeah. Gemini actively translates natural language like, show me databases missing backups in Europe, into the underlying API calls. It automatically flags vulnerabilities across thousands of instances instantly.
So what does this all mean for you as you design your own systems? Ultimately, architectural success is simply matching the shape and scale of your data to the specific mechanics of the engine, whether that's Spanner's atomic clocks or Bigtable's append-only wide columns.
It is. But I'll leave you with a final thought to mull over. We're already at a point where Database Center uses Gemini to govern fleet health via natural language, right?
Yeah.
And AlloyDB has AI vector search natively baked in. So if these systems already understand their own architecture and data semantics, how long until these databases become entirely self-aware?
Wow.
We might be very close to a world where they auto-select, tune, and migrate themselves without human architects needing to make these decisions at all.